Hello everyone, and today we'll be seeing one of the problem from Leetcode. It says count partitions with even some difference. The problem is very straightforward. It says we are provided with an integer nums. Partition is defined as an array, as an index I, where I is within the valid indexes of nums, and splitting the array into two non-empty subarrays such that left subarrays contains these many elements and right contains these. Now return the number of partitions where the difference between sum of the left and right is even. So we need to have a difference between these two partitions, and if the difference is even, then it is a valid partition, and then we need to increase the count, and we need to understand that how many such partitions can exist, and we need to ultimately give the count, such as in this example number 1, we have 10, 10, 3, 7, 6, and such are the partitions. We have 4 partitions overall. That means at each point we can split, and we can understand that hey, it is it is a valid partition. But in this second example, we cannot do so. What makes us think that it is a valid partition? First, that let us say that. So the question says us that we need to have, for valid partitions, we need to have a, okay, oh, it's not zooming up. So for any valid partitions, we need to have a difference within the partition. So if I'll say sum of partition 1 minus sum of partition 2 should be even. So the theory behind a difference can be even is, a difference can be even only when either of the party is even, both of the parties is odd, or, and that's it. If one is even and one is odd, hey, we cannot do that, and that's the reason we need to think, that's the reason we need to understand. So that is one axiom. So axiom 1. The second is, if we subtract, or if we take out an even element from the array, uh, the result of array is, or resultant sum, I would say, is still even. So if I'm provided with an array, let's take this, and if I take out 10, even though if I took out 10, the rest of the sum for this array is still even. Vice versa for odd number of arrays, array with which has sum as odd, that also works. Whereas let's say that 3, 7, 3, 5, 5, okay, this has odd number. So if I took any of the odd, okay, it is not odd because 6, I'll take 7, huh? So if I take one odd number from this, the result over here would be odd. So it would have a condition where odd is to odd, and the condition was earlier with earlier example as 10, 10. What was the next numbers? I just forgot. The next numbers were okay, something similar to next numbers were, give me a minute, 10, 10, 1, 3. Yeah, if we have such kind of number and we took out one number and that was even, then we will left with even. And the entire concept which I'm putting forward is, you need to just check whether it is an even array or whether it is an all odd array. If it is all odd array, that means if we are having a partition as odd, that means the sum would still be even. And the entire thing boils down to only one concept, that hey, we should we should have we should check whether the array is uh, we should check whether the array is even or not, even summed or not. So here we go, understanding if the array is even sum or not by just one loop with int sum as 0 for int I in nums, sum plus equals to I mod 2, because we are just mattered with whether it's even or not. And if the sum mod 2 is 1, that means the entire sum is odd. That means either on the left hand side, like either on the left hand side the odd element would be there, and it would result either odd even or even odd. In that case we need to return 0, because there would be no such subarrays formed. Else we return nums.length minus 1, because no matter what, if the sum is even, I can take out any of the element and the rest of the array is still even. And as we know that even subtracted with even is even, or else if I took out the element as 7 6 which has an odd sum, the rest of the array is still odd. So that's the reason I have entered over this. Let's submit this to check whether it succeeds or not. And yeah, it passed. It is qualifying all the test cases, and this was a good problem for understanding number theory. For more such content, click the video on your right, and I'll see you in the next one.